So since 2018, HAI has distributed funding to researchers across all 7 of the Stanford schools and their collaborators. And this is how we initiate new research, interdisciplinary research, at the cutting edge of artificial intelligence. And I've had the unique privilege since working here of seeing research go from new ideas through our seed grant program to real-world applications. So the next panel, Pushing the Frontiers of Robotics AI, aims to bring together researchers doing interdisciplinary work at the cutting edge of this technology. Professor Karen Liu of Computer Science, HAI-affiliated faculty and co-organizer of this conference, will be moderating. Let's welcome Karen.
Hey, everyone. Welcome to our first panel of the day. So today we're really fortunate to have 3 amazing researchers and leaders in the field of AI and robotics. So the first panelist is Chelsea Finn. You have already seen Chelsea demoing in the earlier talk. Chelsea is my colleague. She's a professor, assistant professor in computer science at Stanford. And she's also the co-founder of the company Physical Intelligence, PI. Chelsea's lab studies intelligence through robotics interaction at scale, and she's interested in expanding the capability of robots and other agents by developing broadly intelligent behaviors. And we also have Wendy Zhu. Wendy is associate professor at Cornell Tech, but Wendy is no stranger to Stanford because before Cornell, Wendy was an executive director of interactive design research at Stanford. And she's interested in areas like human-robot interaction and automated vehicle interface design. She builds interactive devices that can communicate and engage people without intruding and interrupting. And finally, we have Dhruv Shah. Dhruv is a senior researcher at Google DeepMind, research scientist at Google DeepMind. But Dhruv is going to join Princeton University next year as assistant professor. Dhruv is interested in building intelligent and useful robotic systems that can deploy reliably in challenging environments. So now everybody's here. I'm going to start with the first kind of warm-up question by mentioning this one article I read a couple days ago on New York Times. So the editor, Tom Friedman, a lot of people probably know him, a few days ago wrote an article on New York Times posting a question, decade from now, what will journalists say was the most important news story in the fall of 2024 that should have received more attention given the long-term consequences? And he actually gave us 3 examples there. Uber going driverless with Waymo cars, or the result of presidential election. That's number 1. Example number 2, all robot, no humans, Ukrainian air and land warfare, or the result of presidential election. Example 3, humanoid robots dancers on China's televised Lunar New Year's gala, or the result of a presidential election. So he voted for robots every time. Now, question for you guys. Looking back a decade from now, what do you think will be the most important AI robotics development from the last 6 months? And I deliberately say 6 months because we know how fast things move in the last few years in robotics.
I can start. So I will give a very biased answer. So about almost exactly 5 months ago, we shared some of our recent results at Physical Intelligence. Carol earlier today talked a little bit about them. And part of those results were a new foundation model for robotics that can be fine-tuned to different robots. To our knowledge, it's already been used on more than 20 different robot platforms and performs quite well at new tasks and new platforms. But what I actually found the most exciting about our result from November was actually the success of a pre-training and post-training recipe for complex robotic tasks. And in particular, I actually was working quite closely on trying to get the robot to autonomously fold laundry. This is a notoriously challenging task because different articles of clothing can be in all sorts of crumpled states, and the robot has to handle that variability. You cannot, it's very, very challenging to actually model the way that clothes will deform and fold. And so it's very challenging to use, for example, use physics simulators and so forth. And we started with the progression. At the beginning, I think somewhere in like April or May, we got the robot to fold a shirt from a flat state, which was exciting, and got it to do it actually quite well. I did some of the evals myself where it was able to do it 10 times in a row, which is pretty promising. But then once we actually started to try to have it start in a state where the shirt is crumpled, it got a lot harder. And we tried many, many different things to try to get the policy to work well. And a lot of those things failed. We actually spent multiple months on this. And the one thing that really seemed to make the robot work was this pre-training and post-training recipe, where we curated a post-training data set following a particular strategy. And with a diverse pre-training data set plus that curated post-training data set, we were able to actually get the robot to fold like 5 items of laundry, shirts and shorts, and eventually put that into a final demo where the robot both unloaded a dryer and folded 5 items in a row, which I think is, in my opinion, one of the most complex tasks to date. And the exciting thing there isn't necessarily that the robot is folding laundry, but that we have a recipe that can produce that kind of complex behavior in robots. Now, I think that there's a whole host of challenges still to solve in robotics, but that's the result that I'm most excited about from the last 6 months.
Can I jump in? I actually am going to go for, I think presidential elections matter a lot for technological development. I mean, as a person who studies people, I'm also really interested in the history of people. And I think we have to keep in mind as technologists that like one of the things that's amazing is how technological progress basically moves through despite fairly challenging times because of the determination of a lot of people. People find a way to keep working on the problems they think are interesting and important. But I think it would be foolish if we didn't really acknowledge that the way that funding and like priorities in society affect that development. And we are at a really interesting moment where a lot of the development that we've had in the last, I would say like since the 80s has been based on this idea of having a lot of open source software, the idea that development is best done even by proprietary companies together under a shared platform. And I don't know that I think that when I hear people talk about robotics, they have that spirit. And I think it's partly political. I think there's a feeling that this is an age where a few big players will be allowed to win, that you could get that winning by aligning yourself politically with certain people. And you can see the way that the investment community has lined up behind that vision. And so I think that that's the world that we're all living in. We're living in a situation where there's increasing concentration of financial resources and a few big companies already, hold a lot of the world's data. And you can see people are counting on the ability to kind of mine that to gain political affiliation with a few entities. So I think that that's a thing we have to think about, whether we want to align ourselves with that because that is the essence of the moment, or if we want to counter that because we think that is counter to everything that we've built all of our foundations of progress to date.
So, thank you. Well, in general, I completely agree, but I kind of want to, push it back a little bit because thinking about one of the surprise to me in the last 6 months, it was DeepSeek, right?
Yeah.
And that's one example of open source. Would you say that sure we're seeing a lot of large companies start building their things and then they keep everything close, but we also start seeing other philosophy, other ways of
I'm not saying it's a
business.
single-threaded march in one direction, but you can see like people, the reason why DeepSeek had the impact that it did is because people see that there is a dominant paradigm, and this is something that basically contests that paradigm.
I think both of you made very good points. I think the thing that got me very excited in the last 6 months was something that challenged what I believed in. I believed that robotics was so far out that people would always push back. We always thought that having robots around us, having robots in our houses, having cars that drive us was something that was a distant future, maybe at least 12 months ago. And in many different ways, this has been changing in the last 6 months. I'll give 2 examples. One for me is Waymo in San Francisco. I think once the rollout increased to more users in the city and to other cities, now I cannot walk 2 blocks in SF without seeing a Waymo car. And when it started, people took selfies with it. People were wondering whether they should take it. This became a tourist attraction. But in the last couple of months, I don't see anyone stop and pay attention to the car. I bike in the city, and I am very confident when the Waymo is next to me that it's not going to hit me. And I think over time, people became more and more okay with technology around them, and it's really cool to see that maybe this is the vision of robotics in the future, where we will have robots around us. The other version of this, which was tied to some of the releases that Pi0 did last year, and Google DeepMind did a release where we wanted to put out robotic models for robots in the world. And as a researcher, I wasn't sure if anybody would want to use these imperfect models that, they achieve 75% success rates sometimes. Who cares about these models? But the inbound of people with robots, thousands of people who have fleets of robots, not just industrial arms, but also hobbyists picking up $200 robots that they build themselves. And they want to put a small model so it can assemble Lego kits, or it can fold a small piece of shirt on their table. Just that excitement of people wanting to play with these models and with robots in the real world has been very refreshing. And I don't think I saw this a year ago. So hopefully everything we're doing is going to get out there for people, and people will figure out a way to work with it. I hope.
That's cool. Very cool. So I think up to this point today, we're midday through, we have heard of this word foundation models so many times. And I know both Google and Chelsea's company Pi have been pushing out this idea of building a VLA as a solution for a lot of our robotics challenges. What do you think that the right way to go about this foundation models? There are many different ways to use it. Someone talked about earlier that we can build this kind of end-to-end models. You have, VLM, you have vision and language as input, and just have robot action as a direct output of that model. Or some people are, advocating that we should have a more modular approach, where you have a VLN that's doing the high-level planning and output some kind of high-level abstractions, and then you train another model as a low-level policy that can take the action and then take the high-level plan and turn into a low-level actions. So I was wondering what do you guys think about the kind of which approach holds more promise to the future AI robotics? Do they eventually will merge into one approach, or is there a third approach that we should be looking at as well?
I think both of the two approaches are quite promising. I think we've already started to see them merge into one. I think that if you look at many of the major kind of releases of models from Pi, from NVIDIA, from Google, from Figure, we've actually seen hierarchy in these models, where you have one model that is kind of a low level, like a VLA model that's outputting actions directly, and a high level policy that's outputting something like a language vector, or like a sentence, or some sort of latent vector, or something else. And so I think we're already starting to see these merges. In terms of what the future will look like, I think that some sort of merging is likely, in my opinion, but at the same time, I wouldn't necessarily count out either approach. So for example, on the pure VLA front, I didn't think that a single model could do a task that takes the robot 10 minutes, like unloading and folding laundry, but we're able to do that, and without having kind of hierarchy of one high-level policy and one low-level policy. So I think that we'll continue to be surprised by what these models are able to do. And I also think that you can combine hierarchy in a single model in the form of chain of thought, like we've seen in language models, where the robot kind of in a single model thinks through what are the next steps and then execute those next steps within a single model. There's a variety of technical challenges around latency and how quickly you need to run the model that will also affect some of the choices here. And yeah, I think that I'm not taking any sides. I think the science and the results will tell us.
Yep, I don't think I can pick a side either. I think just as Chelsea said, I think robotics will remain a systems problem. I think our models will get better, so we will operate on hierarchies with broader symbols, with more powerful abstractions. But eventually, I think we're going to need progress on both sides to move ahead.
Very cool. Yeah, so I guess we touch on the foundation model. Another thing, is topic that we really have to talk about is humanoid, and we have heard of that a lot today already. So, people are excited about humanoids. That's that's a reality right now. But is the humanoid form really the right one for AI-enabled robots? Some people might argue that, you can imagine you want to have an embodiment to host human-like intelligence and operate in human design world. It makes sense to have a morphology that looks like human. But other people might, argue that, well, humanoids is too complex, it's not stable, and oftentimes it's not the right form for a lot of special tasks. So what do you think about this? Is it, this is definitely not like what Ronnie said, this is not the first time humanoid robotics hype starts. What makes this time different? And are humanoids here to stay, or is just another cycle of over-promising and under-delivering?
I mean, I will say, so I think it's important to acknowledge that the humanoid robot has a really special place in the robotics imagination. Like, we actually have a much longer history of automata and really became robots when we actually started envisioning, the automata taking human form and doing human tasks. So I think because that's like a real origin story for the field. And so, of course, we're always obsessed with it. Every single thing that Rodney says is something I believe in. And I am not so much anti-humanoid form factor, although I think I play that role in the human-robot interaction community. But I'm really pro-diversity of form factor. I think there's so many things that can be done with many different shapes and sizes, and capabilities of robot. If you look at the thing that they tried to do in the DARPA Grand Challenge for robotics, and they had a human do it, it was just hard not to imagine how much better a team of diverse robots could do, kind of accomplish every one of these tasks. And there's absolutely no reason why the robot, which is plastic in form factor, should be constrained in our imagination or our scientific exploration to the humanoid form factor. And so it's really frustrating if you send in grants to do things that are, my research does robotic ottomans and robotic tables and robotic chairs and robotic trash barrels. This seems very humble, but there's so much to learn from it. And if you look at the robots that are really actually starting to happen and starting to be used by people, for example, in warehouses, it looks a lot more like my ottoman than any sort of CB3PO type creature. So I really think that the humanoid focus basically detracts from the whole field and the strengths they could have by learning from a much wider pool of robots.
I have a slightly different perspective on this. So all of those statements are true, and everything Rod said in the morning is true. But something that got me, I remain a skeptic of the humanoid form factor to the point where maybe I don't want to work on it just yet. But the reason why I'm very grateful for what the last 6 to 9 months have been in that space is that the entry barrier for people getting excited about robotics has gone down a lot. The cost of humanoids has gone down by orders of magnitude in the last 2 years. And just the fact that we now have a stable mobile manipulator that you can buy off the shelf and it will work as a research platform, which we did not 2 years ago, that's great. And for that, I am grateful. And I will leave Chelsea to say more.
Yeah, I think we have a lot of humanoid skeptics on this panel. I also think humanoids are overrated in a variety of ways. I think that they're really cool, but there's just so much hype around them that isn't fully justified by some of the practical things. I think there are some arguments for humanoids, for example, like economies of scale in terms of manufacturing. But at the end of the day, there's a lot of benefit to simplicity. There's a lot of benefit to ease of data collection. And right now, it's really much harder to collect data on humanoids than on other platforms. And also, if you think about your kitchen, for example, we already have machines of lots of different form factors, like your dishwasher, your washing machine, your blender, your oven, and so forth. And so I think we can actually build diverse mechanical machines at scale and figure out ways to put intelligence into those machines in a way that will help humans.
Cool. Okay. Now, my next question is about data. When we talk about AI and robotics, data is something that people keep talking about because getting data for robotics is not as easy as in the other domains. So one approach to training AI models for robotics is to, just to kind of like what people in NLP and computer vision do. You collect as much as data as you can, diverse data, and you put it into a single large model during pre-training. But in practice, everybody doing robotics know that we do a lot of curation of the data, right? So the question is, do we worry about that? Do we need to do curation? The curation is just a phase thing. We are doing that because we don't have enough data right now. And once we are able to get enough data, then this issue will just go away. Or is scaling up non-trivial, require more deep understanding of how data interacts with the model in the task that we care about?
I can take a stab at that. I think clean data has always been good, and I think curating data is something which we have done all throughout the history of robot learning. But of late at DeepMind and with the Gemini Robotics program, maybe we've taken a little bit of a gamble in that someone has to find out how diverse we can make our data, and that's something that we have started exploring. So this means data doing a lot of different tasks on a single embodiment, but also data coming from different embodiments, doing very different things in different settings, but also non-robotics data, whether that comes from simulation, from videos, static data that is not interaction, but data that is quote-unquote VLM data, not necessarily applicable to robotics. And we definitely see some early signs that there is transfer. I don't love the word emergent behaviors, because I think as it's been broken down a few times, maybe we're just not looking at the right metrics and we're not quantifying them the right way. If we're just thinking of them on any single metric, it looks like it's a sizable jump that happens beyond a certain scale, but it really is a matter of understanding what data we're putting in and how we're measuring the performance that we're gaining. I think it's early stages. I think it is a bit of a phase. I think we will be scaling up data a lot more, especially now that there's more companies who are willing to collect data on scale. There's really good simulation platforms. There's new technologies in generative AI in terms of video-based generative models. And I think a lot of this is going to come together. I think there's active research going on in what it means to have scaling laws. I think Carol alluded to some of this in his talk. How do you scale up data collection? How do you scale up models? How does that play with real-time inference constraints and so on? But I think this is going to be empirical science, like a lot of things have been in deep learning, and maybe this time next year, I'll have a more concrete answer.
Mm-hmm. That's a good answer.
I don't think we necessarily need to have a dichotomy between like diverse uncurated data and curated data. I think that in kind of a pre-training, post-training world, even like we've seen in language models, you can pre-train on all of the data that you can get your access to. Maybe there's some curation that goes into that with regard to balancing and so forth, but their quantity and diversity is going to be kind of the driving factors. And then in a kind of the post-training setting, that's where I think curation may play a larger role. And so far, the evidence that we've seen is that curation is really crucial for post-training, and actually throwing in all the data you have is worse than fine-tuning on a curated data set. But again, science will, I think, continue to tell if that will stay true.
I mean, I can jump in here. I think one thing is that roboticists tend to make assumptions about what the problem is, and especially when you have the hope of having a general purpose robot. Like almost any data will do, and it can do any task. But I think one of the things that we can learn from looking at the autonomous vehicle advancement, which I hope is kind of happening 10, 15 years ahead of where robotics is that a lot of people assume that the really hard thing for a car would be figuring out how to like manage the physics of driving, or managing different kinds of road or weather conditions, and then they encountered people. People turn out to be quite complicated and different in different places. And people keep telling me that autonomous vehicles are solved, and I was like, where? Where are they solved for? Because there's obviously a lot of places that are still like kind of holy grail type places that you could try to deploy an autonomous vehicle. Like everyone tells me about India. I would love to go to India and understand that situation better. So it'll be decades before we're able to do some of these things. And so you can see that like one of the things that has been a problem is that the robotics community has a blind spot when it comes to people. They basically want to wait until they have a working robot before they deal with people and the tasks and the context that those robots are going to be in. And the thing I'm most excited about is things where people are really thinking about how to deploy the robots in the way they do online learning, use human in the loop, different reality in the loop methods to actually get at the real problems that the real robots will have to solve.
Yeah, I think a lot of the people, roboticists, are trying to make their robots as generalized as possible across different environments. And people, they're a part of the environment, right?
Right.
So do you feel like that the current approach to generalize across environments is not a good way to go when it comes to people?
Well, I think one of the things is that people interact, so the behavior is contingent. Like what you're going to say depends on what I'm going to say, depends on what you're going to say. There's no way anyone can predict what the two of us will say by the end of this conversation, by the end of this panel. And the way that we design the robots assumes that none of that contingency. And so there's no way you could passively collect data from movies looking about interaction and anticipate how a person's going to encounter, treat a robot. You really learn that by doing the probe, by putting the robot in the field with the people and looking at the behavior. And there's not enough of that. We should invest more money in human-robot interaction is what I am saying. So, yeah, but I think that without doing those actual probes, exploring with actual robots in real context, people who are actually trying to do something, it's really hard. And I have to say, when I'm looking at all these wonderful demo videos, it's really cool. But the delta between that and a real-world, in the wild, real-world task is huge. And I think sometimes as roboticists, we stop seeing those deltas, and that's a big deal, because it'll come and get us in the end.
So I don't know, Chelsea and Dhruv, do you feel like data can solve this problem?
I think that we can get data with people, with kind of interactions with people as part of the data. And I think that it's really crucial for the data that robots are trained on to reflect real scenarios. We know from machine learning that things work best if the training data set matches the test scenarios. And so I think that we have a ways to go in robotics in general. And I think that one of the kind of crucial next steps or future steps for robotics is to collect data in the wild in real scenarios. And that there are companies that are doing that, that are deploying robots and so forth. So yeah, I agree that it's crucial to get that kind of data, including data of robots interacting with people.
Yeah, I think there's no way around online learning. There will never be a frozen model that you just put out there on people and it'll be fine. It'll be conditioned on people around it, and it will have to learn and get personalized, and I think that's inevitable.
Well, that fits right into my next question about generalization. So we care a lot about generalization. One of the reasons we need a lot of data, a lot of diverse data, is because we want a robot to generalize, and we already kind of, touch on generalization across different environments. But there are also other dimensions like different tasks, different embodiments. So in your view, what defines a truly generalist robot? What theoretical advancements are necessary to make this happen? Or on the other hand, you can say you don't agree with that. Should we all be striving for the generalist robot vision? Or is it premature when most specialized robots still struggle with reliably completing even the narrowest tasks?
I think that what we've seen in language models is actually that the generalist models are more reliable than the specialist models. I think that if you want, for example, to have a language model or have some sort of AI model help you with coding or to answer a question that you have or something, we'll turn to a general purpose language model. And a lot of the results show that those general purpose language models are better at the specialist tasks, even compared to the models that are trying to specialize on those things. And I think that the bet that I have is that we will see that same trend in robotics as well. And the reason for this is that when you collect diverse data across different tasks, across different environments to train a generalist model, that allows it to actually see a long tail of scenarios and see more scenarios as input than if you tried to only train it on one narrow data set. So I think that developing generalists is very important and actually will succeed more than the specialist models. And I think that the generalization that we want to see is across tasks that the robot is capable of, across environments and situations, ideally also across embodiments as well. And I think this can also improve robustness and performance insofar as it allows you to use more data. But especially tasks and environments.
Just to add on that, I think there is already now early evidence that this is true. Multitask policies trained with a high capacity enough model, fine-tune on specific tasks, post-train on specific tasks, end up being better than single task specialists. And that to me is enough reason to kind of keep going. Something I will say is missing, and we're trying to make some strides towards it, is evaluation, is defining what it means to generalize, to measure it in some abstract way, and then improve on it. This is something which has always been kind of a concern with robotics. How do we benchmark progress? How do we hill climb on metrics that everybody else can also follow along? And I think it's going to be challenging. I don't think there's a magic arrow here. We put out a paper last month with some students at Stanford on trying to categorize what it means to generalize. What are the different ways in which a robot which can do task X should also do task X prime, where X prime is different lighting conditions, different positions, different ways of specifying the task, interventions, ways in which you need to make different behaviors and so on. And it was an enlightening exercise because even though you're starting with a model which, it's let's say 60% success rate in a simulation or in real, and you try to break the policy, it's actually extremely easy to break these models with very small perturbations in different ways. And we found when we evaluated a lot of the current state-of-the-art models that they do struggle in a lot of these different axes. And that should guide how we not only kind of collect data, but how do we have better inductive biases in our models, and how do we improve these models once they're deployed. So more ideas are always welcome in evaluation, and then tracking this down as a community.
A thing I'm really excited about generalization in is understanding human interaction. I mean, if you think, again, I'm going to bring up autonomous vehicles, there's this notion of an operational design domain, which is like, this is an area where the vehicle has been designed to perform, but also has been like, well characterized. So it can't just perform well, it also can't fail, in ways that are dangerous. And so it's very difficult to think about what happens when the vehicle is outside of its operational design domain. And operational design domain can change on an instant. It's not just being on the wrong street. It can be like the weather changes or the lighting changes. And people are amazing at kind of going between operational design domains, and we never think about it. And something that I think is an example of a generalizable skill is that one of the reasons people are really good is if there is a norm or a thing that the robot should be doing, people are really, they just intuitively, without any sort of training, try to guide the robot. We see this in all our robot experiments. And they do this because we do this with each other. We guide one another all the time in day-to-day life. But the thing is, we don't design the robots to pick up on any of the cues. When I'm watching the Pi video and seeing the robot trying to fold a shirt and seeing the constant perturbations, the robot is so determined to fold the shirt. But in a real life setting, if a robot is trying to do something, the person's constantly undoing it, it has a meaning. It's not just a proxy for just physical problems. It has a meaning. And actually, the robot, a socially intelligent robot, would understand the meaning of being constantly countered in the thing it's trying to do. Most of us would up-level and ask, is the thing I'm trying to do a thing I should be trying to do? And that's not a thing we've trained robots to deal with right now.
Right. Yeah, so I think you guys both touched on this really interesting question about what's the human expectation when you ask robot to do a task. And evaluation is one thing. So far, most people evaluate the robot based on the task success rate, right? When you read papers, that's the tables that they always show. But when we have this truly generalist robots, should we evaluate them differently? Kind of like how we evaluate an employee in a company, right? We don't just look at their completion. Well, we definitely look at task completion rate, but we also look at the other qualities like their, does this employee enable other people? What's their communication skills or even leadership, abilities? How do we, start to think about when you have a generalist robot that can do anything that help you? How do we evaluate them in this more holistic sense?
I have two ideas. I think the first one is kind of just what I was saying before. We came up with a set of perturbations, and you try to measure how well does the robot work under certain perturbations. But then we'll never be able to come up with all the perturbations beforehand. So my proposal, a more fun proposal, is in line with like red teaming efforts with these models. So you give completely unseen, naive users your model. You put them in a room, and you give the human a task, and you make the human use the robot do the task. And how many seconds they survive without wanting to break the robot is your metric to track. I think right now we're really bad on that metric. Hopefully, once that number becomes from seconds to minutes, it's the equivalent of how many miles per intervention that you can get for a robot in either a human assistive setting or a human cooperative setting. And eventually, if we believe that the dream for a generalist robot is to do anything around anyone, then it should be a simple kind of a lower bound on that is the human should not want to kill the robot because it doesn't listen to it. And maybe that would be a fun thing that would get us for at least a couple more years because our models are really bad right now.
I come at this, interaction, human factors a little bit more from an industrial design background. And there's a term that we talk about all the time, which is Swiss Army knife. And a Swiss Army knife is something that's bad at everything. I think if we don't actually develop really specific metrics and then do adaptations of our general purpose technology towards a specific task, we just have, these things that are suboptimal in every area.
Well, I have one more question, and before we can open up to the floor, and this is a kind of a completely open-ended question. Which robotics product will be the first to fully utilize AI, and how many years are we from there? And you can answer in any angles you want.
I think cars, which are robots that you sit inside of, are basically leading, the lead test vehicle. I think one of the things that's really interesting is that we are now testing them in the field. We're testing them around people. We're basically encountering all the real world issues, all the different weird operational design domains, culture, human behavior, the whole 9 yards. And I think that's really, really interesting. And I think that that's the first thing it's going to use is kind of understanding of the kind of, at least the verbal, the language understanding of the world to try to actually get a real world understanding of the world.
I'd say this is said at every robotics conference, and I think Rod is here, so I should. We have robot vacuums. We've had them for a while. I would classify them as AI robots, and they've been good enough for a long time. I recently upgraded to, I won't name the company, to a new robot vacuum, and it's actually really good.
Does it have an arm?
I saw that one. That was creepy. I got the one without the arm.
Okay.
One go up on the stairs?
No, it does not go upstairs. But it is AI, whatever AI means. They're getting really good. If I spill something,
if you keep your expectations low, they're awesome.
If you keep your expectations low, they're great. They're great. But maybe on a more serious note, I think there is a version of an intelligent home robot that will be fun. This could be something as simple as a robot that moves dishes from the sink to the dishwasher. It's the one that everyone talks about. I think we can nail that task to 100% success rate in any kitchen. But I think we're still many years away from a robot that'll actually be there so that when my kids are next to that robot, it doesn't smack them in the face because the kid wore a weird t-shirt today. And I think the only way to get there is kind of what's happening in autonomous driving, having these robots put out there and learning on the job.
I think if I were to scope it to robotic manipulation, I think it would, I'm not going to name a particular task or domain, but I think it would be a domain where you don't have to be perfectly reliable all the time. I think if you look at a lot of the successful examples of AI technologies that are widely deployed, like recommender systems or language models, they're not perfect. And the reason why that's okay is that they're being consumed by people. So expert coders, for example, are getting help and then looking at the predictions of the model and then using that to inform what they're going to type rather than having the AI system type directly. Now, I think autonomous driving and some of the successes we've seen with like Waymo, for example, is a actually somewhat of a counterexample to this, where there is actually very high reliability, although part of that reliability comes from also detecting when an intervention is needed. But I think that if we can find places where robotics will be useful, even with a success rate that isn't 100% or 99.999%, I think that those are the scenarios we'll see AI-powered robot manipulation first.
Right. Well, we have probably 10 more minutes or so to discuss interesting question with our panelists. If anyone has questions, Dorsa?
All right, so yeah, thanks for the panel, everyone. So I think there's a recipe that you guys are all talking about, which is this recipe that we are borrowing from the language land of doing like pre-training and post-training and collecting a lot of data and like throwing a lot of compute. And under that recipe, like if you follow that recipe, like I think we can all envision something out of robotics in the next year or two. What do you think is a major thing that is missing, like if you just follow that recipe as is? And what is like, I don't know, main like technical like innovation that you think we should do differently, like in robotics to kind of like address like some of those things that maybe we are overlooking, especially like from your experience with these models? What do you think is surprisingly harder and it wouldn't be solved with this recipe?
I think one of the big missing pieces is reliability of these models and also like speed to some extent as well. I think that for speed, you need either better teleoperation interfaces for better data or post-training algorithms that can online improve. And for reliability, I think that we need kind of online like reinforcement learning style techniques. I think that we have a lot of ideas for how to add like a reinforcement learning system on top of these recipes, but I don't think that it has been done at scale in robotics yet, and there's a lot of open questions on how best to incorporate that into a recipe.
I think a recipe is a very strong word, right? Recipe implies that you follow the, step by step, you get exactly the product you hope to get.
Some people cook that way.
Yeah, so I thought it was interesting. People start using the word recipe instead of a theory or algorithm.
Thank you so much. Have the impression that this whole thing is very hungry about data. A lot of data, a lot of data, a lot of data. And then two questions. One is there any way to use some small data smartly? That's one. Second is the cost of data. And there's very, very expensive. And then how do you justify, what we're doing? Thank you.
I can take that. I think the reason the whole generalist robot model idea is very, very inspiring is that if you assume that there is a way to have a foundation model, we would define it in different ways, but if there is a way to have a starting point on top of which you can do adaptation with a very small number of demos, that is the vision that is driving the entire research program here. I think currently maybe we're in a regime where if you amortize the cost of pre-training, we're in the regime of 100 to 1,000 demos on your target robot or task or your house or however you define your task. And I think as a field, we have gone down from 5,000 to 1,000 to maybe 500 in the last year. So there is really some promise that eventually you're going to be in a place where this is happening really, really fast on the job. And then there's the online aspect of this. There's bodies of work that do zero-shot and one-shot transfers. So I think that the motivation really is to be in a regime where you don't have to spend a lot of time and effort collecting that data. And even though pre-training right now is compute and data hungry, that would be something you would amortize. But maybe Chelsea.
Yeah, I've worked a lot with small data sets. 10 years ago, we were training neural networks on like 15 minutes of data to do various tasks like screwing on a cap of a water bottle, using a spatula to lift objects, and so forth. You can do some kind of cool stuff with it, but the policies don't generalize. And when you're in the real world, you need to be able to handle all sorts of scenarios that might be thrown at you. And then on your second question around the cost of data, I think that my experiences over the past year is actually that it's been cheaper than I expected and cheaper than what I think a lot of people think it is. I also think that the number of people using their hands to do physical labor in the world is enormous, and if we can use, if we can find ways for that to be data, then whether it be like literally using videos of people or actually augmenting that with robots in some way, I think that the cost of data collection will also go down dramatically.
I do like to think about what are the regimes in which like the data-driven approach has limitations. Like around a lot of the very safety critical things, it's so expensive to fail that you have to think very hard. You can't just, like you're saying, fault-tolerant, tasks basically do really well with this data regime. But like I think thinking about how we want to handle those situations is interesting. Doing online learning, sometimes the interactions you have are sparse, quite expensive, not in terms of money, just in terms of how long you have before people run out of patience. So there's a lot of these things where I think there is some more economic approaches that we should also be considering.
Mm-hmm. Yeah, one good example of collecting a lot of data without, a lot of, huge costs is autonomous vehicle, right? Like when people are driving, but they're also producing data. So if we can somehow make while doing something that's meaningful and functional, but also collecting data, making them into one thing, one algorithm, one model, then that would be useful.
Thanks. This has been fascinating. I was just kind of curious. I'm trying to imagine in this future where this technology is more broadly accessible. And what might that look like? I grew up during the computer revolution. I was a kid, and my parents got a computer, and I got to do these things with it and use my imagination. So now, if your technology has that sort of opportunity to go out in the world, and now someone has an idea, and they want to do something with the robot that's never been done before, so there's not going to be that data. How does that work? So they're not writing code. Do they have to figure out a strategy for training it? Or I'm just very curious about your perspective from a human-centric, community-driven, perspective. What would that future look like?
You can go ahead.
I think robotics is interaction limited, and then those are the questions that we should be asking. I am really interested in the scenario where we have like multiple robots in the home. Like I remember when it was kind of like pie in the sky to think, a computer in every home, and now everyone's got like multiple, computers everywhere. So if you have the robotic technology in your environment, how are you going to interact with it? I think the technology is actually something I'm sure will happen. How we're going to interact with it, that's the thing I think we actually have to design well, and if we don't, people won't use it.
I love this question. I haven't given it as much thought as I would like. But I guess to put something out there, I think like when I was a kid, I worked with like Lego Mindstorm robots, and there was this high-level programming language where you could have blocks to say like move forward, move left, and you could have a for loop and if conditions and so forth. And I think that we can have that kind of level of interaction with neural network models as well, with robots. And it could be, for example, the prompts to a model where you say like pick up if you see this, then pick up this object. If you see this, then turn right, those sorts of things. And I don't think that the way that technology is developing, I think it's compatible with that kind of interaction with humans. Definitely a lot of work to do on a variety of fronts to make that happen. But I think that I have hopes that something like that is feasible.
The version of this that came to mind when you were asking the question and when you were describing it was Scratch as a programming language. When kids are introduced to programming, they have these pick-and-place blocks where they can just write long pieces of code. 10 years ago, this was still the introduction to programming for most people. Something that looks like that would be really cool. I think today the version of that is your own personal language model. You ask it to make a game for you, and it makes a game for you in a minute. So now you have the sandbox where you're only limited by how fast you can come up with an idea, and you have this game that's ready for you in a web browser. I think the version of that would look like a 3D world for kids to interact with and to explore the physics of things, to understand how objects interact, And this is something that they are either through language, either through some abstract version of code, whatever coding looks like 50 years from now. That would be very cool.
Okay, I think this is all the time we have. Well, let's give a round of applause to our fantastic panelists. Thank you so much.